Hello friends, I am Balaji Rao. Welcome to BR Max class. In the first class of differentiation, we learned 23 derivative formulas. In that, you just learned that derivative of sine inverse x is 1 divided by square root of 1 minus x square. In this class, we are going to learn why derivative of sine inverse x is 1 divided by square root of 1 minus x square. Why derivative of tan inverse x is 1 divided by 1 plus x square. All those things we are going to learn in this class. Luckily, all these problems follows the same pattern. So, if you try to understand first problem, second problem, then remaining all derivations you can understand very easily. In this class, we are going to learn proofs of derivatives of inverse trigonometric functions. To avoid unnecessary confusion, I am going to disappear now. Whenever necessary, I will come back and I will instruct you. Without much delay, let's begin the class.
You observe this one. D by dx of sine inverse of x is 1 divided by square root of 1 minus x square. This we learn as a formula in first class only. But in this class, we are going to learn proofs of all derivatives of inverse trigonometric functions. To understand this proof, you need to know three formulas. Let's see our formula box. To do this proof, you need to know three formulas. First formula. You see this formula, sine inverse x equal to theta if and only if x equal to sine theta. This is the formula we learned from inverse trigonometric functions chapter. Whenever you see sine inverse x equal to theta, there you can write x equal to sine theta. This is the second formula. You see this one? In derivative formulas, we learn this. Derivative of sine x with respect to x is cos x. In trigonometry, three main trigonometric identities are there. This is the first trigonometric identity. Sine square theta plus cos square theta equal to 1. Then what is cos square theta from this? Cos square theta is 1 minus sine square theta. These three formulas we are going to use while doing proof of this result. To prove derivative of sine inverse x is 1 divided by square root of 1 minus x square, what I will do, I will take this sine inverse x equal to y. You look here, I taken sine inverse x equal to y. You can take sine inverse x equal to theta also, but I consider here sine inverse x as y. As I considered the sine inverse x as y, I need to calculate d by dx of y. Please try to understand. As I considered the sine inverse x as y, I need to calculate d by dx of y. Okay, keep that in your mind. Now, you see this point, sine inverse x equal to y. You see this formula box, whenever we see sine inverse x equal to theta, I can write x equal to sine theta. So here, sine inverse x equal to y is there. No? From this formula, what I can write? I can write x equal to sine y. You just take sine inverse to this side. X equal to sine y. Okay. Now, what I'll do, I'll differentiate with respect to x on both sides. Look here. This equation is there now. For this equation, I'll differentiate with respect to x on both sides. Differentiating this equation with respect to x on both sides means, for this equation, you just write d by dx on both sides like this. I just written d by dx to this equation on both sides, which indicates that I am differentiating this equation with respect to x on both sides. Now, you observe this one. I need to differentiate this d by dx of x. From the beginning onwards, I am saying that we will use this very frequently. You need to memorize this. D by dx of x is 1. Derivative of x with respect to x is 1. Now, you observe this one. D by dx of sine y. In last class, all the problems we did this type only. D by dx of sine y. How to calculate this? D by dx, it means I am differentiating with respect to x. Here, given function is sine y. The given function is in terms of y. Given function is in terms of y. We are differentiating with respect to x. Both are different. So, how to write the answer? As you know, derivative of sine x is cos x. Look here. As you know, derivative of sine x is cos x. What you will write? Derivative of sine y, you will write cos y first. You will write cos y first. After writing cos y into, as the given function is in terms of y, we are differentiating with respect to x. As these two are different, we will write dy by dx like this. So d by dx of sin y is what? D by dx of sin y is cos y into dy by dx. In last class, we did all the problems of this type only. Please go through that class. That class is very important. Here, once again you come back here. As I consider this as y, I am trying to calculate d by dx of y. D by dx of y is nothing but dy by dx. Please keep this point in your mind. You can observe here dy by dx is there. I am trying for dy by dx. You see this one. Dy by dx equal to 1 divided by cos y. I got this from this step. I hope you are understanding. Okay. Here, very frequently used step, dy by dx is nothing but d by dx of y. What I am trying to say here, dy by dx of y, both are same. You see this formula, sin square theta plus cos square theta equal to 1, then cos square theta equal to 1 minus sin square theta. Na? For this formula, you apply square root on both sides. If you apply square root on both sides, in left hand side, this square root 2 will get cancelled. What you will get here in the left hand side, you will get cos theta. So what is cos theta? Cos theta can be written as square root of 1 minus sin square theta. So here cos y can be written as square root of 1 minus sin square y. I hope you are understanding. Trigonometry formula. To do calculus, you must be good in trigonometry formulas. I did a video on trigonometry formulas. You can go through that class. What I am trying to say, cos y can be written as square root of 1 minus sin square y by using trigonometry formula. Okay, you see here d by dx of y. Y is what? You observe what is y? Y is sin inverse x. In the beginning, I taken sin inverse x as y. So what I'll do, in place of this y, I'll write sin inverse x like this. You please look here. D by dx of y is there now. In this, in place of y, I written sin inverse x. So this side what I got? D by left hand side what I got? D by dx of sin inverse x equal to 1 divided by square root of 1 minus sin square y. Sin y is what? Look here. Sin y is what? Sin y is x. In the beginning we got this step. What is sin y? Sin y is x. So here in sin square y is nothing but sin y whole square. Sin y whole square means, as you know, sin y is x. Sin y whole square is x square. I hope you understand this. So finally what I got, d by dx of sin inverse x is 1 divided by square root of 1 minus x square. I hope you understand this.
Please stay focused to understand the things clearly. Stay with me. These are very easy problems.
Now you see this second result, d by dx of cos inverse x is minus 1 divided by square root of 1 minus x square. This we learn as a formula in first class. In this class I am going to derive this result. First we will see the formula box. What formulas we are going to use while proving this result. You observe this first one. Cos inverse x equal to theta if and only if x equal to cos theta. This is the formula we learned from inverse trigonometric functions chapter. And second formula, derivative of cos x with respect to x is minus sin x. This is the derivative formula we learned in first class of differentiation. From this, sin square theta is 1 minus cos square theta. These three formulas I am going to use in this result. Okay, first one, d by dx of cos inverse of x. In this, I'll take this cos inverse x equal to y. You see here, I taken cos inverse x equal to y. When I taken cos inverse x equal to y, you need to keep one point in your mind. I am calculating d by dx of y. D by dx of y is nothing but dy by dx. So I am trying to calculate dy by dx. See here, I taken cos inverse x equal to y. From this definition of inverse cosine function, whenever cos inverse x equal to theta, I can write x equal to cos theta. Like that, when cos inverse x equal to y, I can write that x equal to cos y. Just take cos inverse to this side. X equal to cos y. I hope you understand. What I'll do now, I'll differentiate with respect to x on both sides. Differentiating with respect to x on both sides means I'll just write d by dx to this equation on both sides. You observe this one. D by dx of x. I written d by dx to this part, and d by dx of cos y. I just written d by dx to this part. This step indicates that I am differentiating this with respect to x on both sides. Now see, d by dx of x. You need to memorize this. Derivative of x with respect to x is 1. I written 1 here. Now you look this. d by dx of cos y. Here d by dx means what? I am differentiating with respect to x. Given function is cos y. Given function is in terms of y. So here given function is in terms of y. We are differentiating with respect to x. As these two are different, how we write the answer? Look here. As you know, derivative of cos x is minus sin x. Derivative of cos y is minus sin y. You write first. Afterwards into. As given function is in terms of y, we are differentiating with respect to x. As these two are different, you just write dy by dx. You observe in this equation dy by dx is there. In the beginning I said, as you considered this as y, I am trying for dy by dx. So further, if I simplify this, you take minus sin y to the left hand side, you will get dy by dx. You see this step, dy by dx equal to minus 1 divided by sin y. I got this from this step only. Dy by dx is same as d by dx of y. In last problem also we discussed this. From now onwards we are going to use this very frequently. Dy by dx is same as d by dx of y. Here sin y is there. Na? You observe this one. Here sin square theta equal to 1 minus cos square theta. Na? You apply square root on both sides. Here this square root, this 2 will get cancelled. Sin theta can be written as 1 divided by square root of 1 minus cos square theta. So here sin y can be written as square root of 1 minus cos square y. This is the formula we learned from trigonometry. Okay. So in place of sin y, I written square root of 1 minus cos square y. See further, d by dx of what is y? See, in the beginning only, I taken cos inverse x as y. So what I'll do now, in place of y, I'll write cos inverse x because I know y is cos inverse x. So d by dx of cos inverse x I got. See here, cos square y means cos y whole square. Cos square y means cos y whole square. See here, what is cos y? Cos y is x. So cos y whole square is x square. So in place of cos square y, you can write x square. So what happened? Finally, I got derivative of cos inverse x with respect to x is minus 1 divided by square root of 1 minus x square.
I hope that you understand the pattern, in what pattern we are deriving these results. Please stay focused, do not deviate. You can understand all these things very easily.
You see this third one, d by dx of tan inverse x. Derivative of tan inverse x with respect to x is 1 divided by 1 plus x square. I am going to prove this result. To prove this result, what formulas we are going to use? You see the formula box. Tan inverse x equal to theta if and only if x equal to tan theta. This is the formula we learned from inverse trigonometric functions. Derivative of tan x with respect to x is secant square x. This is the formula we learned in differentiation first class. In trigonometric identities, we know this formula 1 plus tan square theta equal to secant square theta. Okay. To prove this result, what I'll do, I'll take this tan inverse x as y. You see here, I taken tan inverse x equal to y. As I taken tan inverse x equal to y, what I am trying for? As you taken this expression as y, you are trying to calculate d by dx of y. D by dx of y is nothing but dy by dx. So I am trying to calculate dy by dx. You keep that point in your mind. Now, as I taken tan inverse x equal to y, from the definition of a inverse tangent function, whenever tan inverse x equal to theta, I can write x equal to tan theta. Here, tan inverse x equal to y is there, na? So what I can write here? I can write x equal to tan y. I hope you are understanding. Now what I'll do, I'll differentiate this equation with respect to x on both sides. You see here what I written? I differentiating with respect to x on both sides. Differentiating this equation with respect to x on both sides is nothing but just write d by dx to this on both sides like this. So I am just differentiating this equation with respect to x on both sides. See, this is again we are using the formula. Derivative of x with respect to x formula is what? Is 1. So I written 1 here. Now d by dx of tan y. How to differentiate this? You observe here. D by dx means I am differentiating with respect to x. Tan y means given function is in terms of y. As given function is in terms of y, we are differentiating with respect to x. As both are different, how to write the answer? As you know, derivative of tan x, look here, as you know, derivative of tan x is secant square x. Derivative of tan y, you write it as secant square y. You write that first. You write it as secant square y. Into, Here the function is in terms of y. We are differentiating with respect to x. As these two are different, you just write dy by dx like this into dy by dx. I hope you are understanding. You observe this equation. In this equation dy by dx is there. In this equation dy by dx is there. In the beginning also I said, as I considered this as y, dy by dx of y is nothing but dy by dx. Now from this step, how to get dy by dx? You just take secant square y to the left hand side. You see, dy by dx equal to 1 divided by secant square y. I got this step from this. So dy by dx equal to 1 divided by secant square y. Okay. Dy by dx I can write it as dy by dx of y. Dy by dx and dy by dx of y both are same only. Okay. 1 divided by secant square y. You know this formula. See, secant square theta equal to 1 plus tan square theta. So secant square y can be written as 1 plus tan square y. This is trigonometric identity. In trigonometry chapter we learn this formula. So here secant square y is there. Now this secant square y can be written as 1 plus tan square y. Look here, secant square y, that is 1 plus tan square y. I hope you are understanding. Now you observe this d by dx of y. Here y is there. Now what is y? In the beginning I considered tan inverse x as y. Now what I'll do, in place of this y, I'll write this tan inverse x. So in place of y, I written tan inverse x. So left hand side what I got, d by dx of tan inverse x. Here you observe right hand side part 1 I written as it is from the above step divided by this 1 plus also as it is I written from the above step tan square y. Tan square y can be written as tan y whole square. Tan square y can be written as tan y whole square. What is tan y? Tan y is x. You observe this step. What is tan y? Tan y is x. So tan square y is tan y whole square. As tan y is x, this can be written as x square. So finally what happened? I got d by dx of tan inverse x is 1 divided by 1 plus x square. That is what we are trying to prove. You see this fourth result, d by dx of cot inverse x equal to minus 1 divided by 1 plus x square. I am going to prove this result. To prove this result, what formulas we will use? Let's see the formula box. Cot inverse x equal to theta, then I can write x equal to cot theta. This is the formula we learned from inverse trigonometric functions chapter. Derivative of cot x with respect to x is minus cosecant square x. In trigonometric identities, we know this formula 1 plus cot square x equal to cosecant square x. Now, to prove this result, I'll take this cot inverse x equal to y. See here, I taken cot inverse x equal to y. As you taken cot inverse x equal to y, you are trying to calculate d by dx of y. D by dx of y is nothing but dy by dx. So you keep it in your mind, I am trying to calculate dy by dx. So as I taken cot inverse x equal to y, from the definition of inverse cotangent function, from this formula, I can write x equal to cot y. So, whenever cot inverse x equal to y, I can write x equal to cot y. Now, what I'll do for this equation, I'll differentiate with respect to x on both sides. Differentiating with respect to x on both sides means for this equation, you just write d by dx on both sides like this. Look here, d by dx of x equal to d by dx of cot y. I just written d by dx to this equation on both sides. Okay. See, very frequently we are using this. Derivative of x with respect to x is what? Is 1. Now, d by dx of cot y. How to differentiate this? D by dx, that means I am differentiating this with respect to x. Cot y, given function is in terms of y. Given function is in terms of y, we are differentiating with respect to x. As these two are different, how to write its answer? As you know, derivative of cot x is minus cosecant square x. As you know this formula, derivative of cot y, you write it as minus cosecant square y into, as the function is in terms of y, we are differentiating with respect to x. As these two are different, so you write into dy by dx. Okay. And the beginning only I said, as you consider this as y, we are trying to calculate dy by dx. You observe here, I got dy by dx in this equation. You see here, dy by dx is there. So what I'll do, from this equation, I'll write what is dy by dx. You observe this step, dy by dx equal to minus 1 divided by cosecant square y. You just, I got this step from this. you just take cosecant square y to the left hand side, then you will get this. dy by dx is nothing but dy dx of y. That is what I written here. Okay, minus 1 as it is from the above step. This cosecant square y, you see this formula 1 plus cot square x is cosecant square x na. So cosecant square x can be written as 1 plus cot square x. So in place of cosecant square y, I can write 1 plus cot square y. This is the trigonometric identity formula. This formula we learn from trigonometry. D by dx of y. Here y is there. Now what is y? In the beginning only we know what is y. What is y? Y is cot inverse x. So here in place of this y, I will write cot inverse x, because I know y is nothing but cot inverse x. Okay, here left hand side I got d by dx of cot inverse x. In this minus 1 I written as it is from the above step, divided by 1 plus here x square is there. Here cot square y. Cot square y means cot y whole square. What is cot y? Cot y is x we got here na? Cot y is x. Cot square y means cot y whole square. Cot y whole square means x square. I hope you are understanding this. So finally what I got d by dx of cot inverse x is minus 1 divided by 1 plus x square. You observe this, d by dx of secant inverse x equal to 1 divided by x into square root of x square minus 1. I am going to prove this result. To prove this result, what formulas we will use? Let's see the formula box. You see, this is the formula we learned from inverse trigonometric functions. Whenever you see secant inverse x equal theta, then you can write x equal to secant theta. This is the formula we learned from differentiation chapter. Derivative of secant x with respect to x is secant x into tan x. And this is the trigonometric identity. 1 plus tan square x is secant square x. Okay. To prove this result, what I'll do, I'll take the secant inverse x equal to y. See here, I taken secant inverse x equal to y. As I taken secant inverse x equal to y, you try to keep in your mind, I am trying to calculate d by dx of y, which is same as dy by dx. As I taken secant inverse x equal to y, from this step, from the definition of inverse secant function, secant inverse x equal to y, then I can write x equal to secant y. Okay, now what I'll do for this equation, I'll differentiate with respect to x on both sides. Differentiating with respect to x on both sides is nothing but you just write d by dx to this equation on both sides like this. So here d by dx of x equal to d by dx of secant y. You can observe I just written d by dx to this equation on both sides. It indicates I am differentiating with respect to x on both sides. Okay. Derivative of x with respect to x is 1. This is the formula we are using very frequently. Now d by dx of secant y. You need to write answer carefully. Why? Because secant y given function is in terms of y. D by dx means I am differentiating with respect to x. As the function is in terms of y, we are differentiating with respect to x. As these two are different, how to write its answer? You know d by dx of secant x is secant x into tan x. So as you know, derivative of secant x with respect to x is secant x into tan x. Derivative of secant y, you write it as secant y into tan y first. Afterwards, as the function is in terms of y, we are differentiating with respect to x. As these two are different, you just write dy by dx. Now, in the beginning only I said, as you are considering this as y, you are trying to calculate dy by dx. In this equation, we got dy by dx. So from this equation, I can write dy by dx. You see here, dy by dx equal to 1 divided by secant y into tan y. I got this step from this. Okay. Now dy by dx, I can write it as dy by dx of y. Both are same, I am saying from the beginning of this class. Okay. Now further, how we simplify this, that is important. 1 divided by secant y, I written as it is. Tan y. What is tan y? You look here this formula. What is tan square x? You take 1 to the right hand side. What is tan square x? Tan square x is secant square x minus 1. Tan square x is secant square x minus 1. What is tan x? Apply square root on both sides. Tan x is square root of secant square x minus 1. Try to understand. From this formula, you can easily understand that tan x is square root of secant square x minus 1. So here tan y is there na. Tan y can be written as square root of secant square y minus 1. Tan y can be written as square root of secant square y minus 1. This is from the trigonometry formula. Further, if I simplify this, see d by dx of y. You see here, what is y? In the beginning, I taken secant inverse x as y. So in place of y, I'll write secant inverse x. In the left hand side, I got dy dx of secant inverse x. Okay, that equal to 1 I written as it is from the numerator divided by secant y. What is secant y? Secant y is x. So in place of secant y, I written x here. Okay, into square root of secant square y. Secant square y can be written as x square. So in place of secant square y, I written x square here. X square minus 1. I hope you understand this. So I proved that derivative of secant inverse x with respect to x is 1 divided by x into square root of x square minus 1. D by dx of cosecant inverse x equal to minus 1 divided by x into root over x square minus 1. To prove this result, what formulas we'll use? You just see the formula box. Cosecant inverse x equal to theta if and only if x equal to cosecant theta. This we learned from inverse trigonometric functions chapter. D by dx of cosecant x. Derivative of cosecant x with respect to x is minus cosecant x into cot x. This is the derivative formula we learned in first class of differentiation chapter. And 1 plus cot square x equal to cosecant square x. This is the trigonometric identity. Now, to prove this result, I'll take this cosecant inverse x equal to y. You see here, I taken cosecant inverse x equal to y. From this formula, this can be written as x equal to cosecant y. Now, what I'll do for this equation, I'll differentiate with respect to x on both sides. You observe this step. I written dy dx of x equal to dy dx of cosecant y. That means I am differentiating this equation with respect to x on both sides. Dy dx of x. You know derivative of x with respect to x is 1. So I'll written 1 here. Now dy dx of cosecant y. Here important thing you need to understand, dy dx means I am differentiating with respect to x. Cosecant y means given function is in terms of y. As given function is in terms of y, we are differentiating with respect to x. As these two are different, how we write its answer, that is important. As you know, derivative of cosecant x with respect to x is minus cosecant x into cot x. You just write derivative of cosecant y as minus cosecant y into cot y from this. As the given function is in terms of y, we are differentiating with respect to x. As these two are different, you just write dy by dx. Okay. As you consider this as y, we are trying to calculate dy by dx. In this equation, you can identify here dy by dx is there. So from this equation, I'll write dy by dx. You look here, dy by dx equal to minus 1 divided by cosecant y into cot y. I got from this step only. Okay. Now dy by dx can be written as dy by dx of y. This cot y is there, no? From this formula, cot x is square root of cosecant square x minus 1. So cot y is square root of cosecant square y minus 1. You can understand this. This is trigonometry formula. Minus 1 divided by x. Here you see what is cosecant y? Cosecant y is x. You see here, cosecant y is x. So in place of cosecant y, I written x into square root of cosecant square y minus 1. Cosecant square y is what? Square this on both sides. Cosecant square y is x square. So in place of cosecant square y, I can write x square minus 1. So dy by dx of cosecant inverse x is minus 1 divided by x into square root of x square minus 1. Hence, we proved this result.
Dear friends, creating these videos takes so much of time. If you like this video, please drop a like. I'll be very happy. And share these videos with your friends so that they'll also will get benefit from my classes. If you are not yet subscribed to my channel, subscribe now. Thanks for watching. Have a great day. Bye.